Now that we know how to use our radicals, we can start looking at our right triangles. First, we're going to talk about Pythagorean theorem, which you probably know somewhere, maybe 6th, 7th grade, you probably learned about it, were able to use it. We're going to probably get a little bit maybe more specific this round, since we're going to not have decimal answers, we're going to have radical answers. So write this down, pause, hit play, move on. So here is our Pythagorean theorem. This is our formula right here. Usually we hear it backwards. We hear a squared plus b squared equals c squared. You don't have to memorize it. You probably will, because we're going to use it so much right now. But it will be on the board for you. The key is that you know that C is the hypotenuse. Okay, and the hypotenuse is, you probably learned it as the longest side. It's the side opposite of the right angle. You can't always tell if it's the longest side, but you should always know what's your right angle, and so you should be able to always say it is that angle, that side, right opposite of our right angle. Okay? It doesn't matter which one of these sides or legs that you call A or B. What matters is that your hypotenuse gets in the right spot. Okay? So write all this down. I'll erase my scribbles so that you can write down, just clear what's on the screen. And after you are done, push play again, and we'll do some examples. Oh, sorry, I forgot. Before we do examples, you need to write down this sentence right there. Okay, you don't have to write down this big old table. So the thing about Pythagorean triples is that there are some sets of sides of right triangles that we just see a lot. Okay, we see 3, 4, 5 all the time, 5, 12, 13. Those are the two most popular. And then these guys we see sometimes too. Okay, and so the triples would be any multiple. So 3, 4, 5, all of those times 2 would give us 6, 8, 10. 3, 4, 5 times 3 would give us 9, 12, 15. So if you can see, it's 3 times whatever, 4 times whatever, 5 times whatever, but as long as it's the same whatever. Okay, same thing with the 5, 12, 13. That's how we get 10, 24, 26, etc. Again, you don't have to memorize these. You just have to know that they exist. Okay, and some of them you might start to see. You might see a right triangle that has a 3 and a 4, and I know the other side's 5. Okay, that is the most common one that you see, the 3, 4, 5. That's really the only triple that I recognize right away. Sometimes I do this one. Whatever. I'd rather just do Pythagorean theorem. It's easier than memorizing random numbers. So let's practice. Remember that you have to have a right triangle. Okay? The key here is you have a right triangle. You know two sides. You're looking for the third side. Okay? That's why we're using Pythagorean theorem, because we have a right triangle. We know two sides. We're looking for the third side. Okay? We will learn in this chapter ways to, if we only know one side, we might be able to figure it out. Okay? But Pythagorean theorem is when we know two sides. So, and don't forget, it has to be a right triangle. This whole chapter 9 is all about right triangles. So if you don't have a right triangle, you can't do anything that we're trying to do in math in chapter 9. You'll get right triangles every time in math chapter 9. Don't worry. Oh, not every time. Well, you'll see. So we need to find the value of x. So we're going to use our a squared plus b squared equals c squared. Okay. The key is, which one of these is our hypotenuse? Well, remember, it's the one opposite of our right angle. So that means x is our hypotenuse. I don't know where that circle went. So that means our x is what goes here. And then it doesn't matter which of these you put. Most people usually put the lower number first. It doesn't matter. You could have done 12 squared plus 5 squared, etc. Okay, doesn't matter. And then we do the math. So 5 squared is 25, 12 squared is 144, and that all still equals x squared. 25 plus 44 is 169, still equals x squared. Okay, and then to get rid of the x squared, we have to take the square root of both sides. Always check, if you don't know, to see if this is the square root of whatever your radicand is a whole number or not. In this case it is, so we are done. X equals 13. You might notice 5, 12, 13 is one of our triples. Okay? The instructions on the notes will all say, tell whether the side lengths form a Pythagorean triple. You don't have to tell me that. Okay? So we're done because that's all we wanted was x. Make sure that you have written down this example, or maybe you write down this example instead. Just make sure you write down several examples. So again, we're going to use our a squared plus b squared equals c squared. We are going to, oops, sorry, wrong button. We are going to try to figure out what x is. Okay, first we need to think about which of these is our hypotenuse. Well, opposite of the right angle is our hypotenuse, so x is our hypotenuse, so it's going to go at the end. And notice I'm doing on purpose, I'm doing it backwards this time, just so you can see it both ways. It doesn't make a difference if you put c squared equals or the equal c squared at the end. It doesn't matter. And again, it doesn't matter which one of these goes in which order. I'm going to do 5 squared plus 4 squared. And then we do the math. So we've still got x squared. 5 squared is still 25. 4 squared is still 16. That gives us 41. So x squared equals 41. So we're going to take the square root of both of those. I'm going to put in my calculator to see what happens. Square root of 41 is some decimal. We cannot have decimal answers. No decimals. None. Okay? Because we now know how to simplify. Okay? So, if the square root of 41 simplifies, you need to simplify it. It doesn't. Nothing goes into 41. It is prime. So that is your answer right there. Not 6.4. You give me a decimal answer, your whole problem is wrong. Okay, so on this one, we know we need to figure out what the hypotenuse is. Oh, the hypotenuse is 25. Okay, so that means this is our A and our B. Doesn't matter which one's which. Okay, so that means we've got x squared plus 15 squared. Again, you could do that in the other order. Most people like to put their x first. Equals 25 squared. The absolute number one place people mess up is you do not take the 30 seconds or 3 seconds to figure out which one of your numbers information is your hypotenuse. And most students who mess this up, they just assume that x is the hypotenuse, which it's not in this case. So x squared plus 15 squared is 225, and 25 squared is 625. So now I have to subtract that to get just my x squared. And that should be 400, right? Yep. Okay. And then we take the square root of both. And we get x equals, okay, well, let's check. Square root of 400 is actually 20. So we're done. Hope I have an example where we have to simplify. If not, I'll make one up. Okay, so here is kind of a real-world problem. You're trying to figure out the length of the wire that's holding up your flagpole. Okay, this is actually something that is going to happen at my house. Not a flagpole, an antenna pole. But I have to figure out how long the guy wires should be that support them. Okay, so you don't have to do this problem twice, right? You have a triangle, a triangle over here and a triangle over here, but they're the same triangle. So you're really only looking at one of the triangles, right? Okay, so we've got a right triangle. There is our hypotenuse is our x, right? So we're going to have x squared equals 8.5 squared, that's this guy. And then this is this, so 15.1 squared. Okay? And so x squared equals 8.5 squared gives me 72.25 plus 15.1 squared, which is 228.01. Add those two things up, and I'm going to get that x squared equals 300.26. Okay? Do not round that to 300. Okay? So we take the square root of both. Okay? Now, because this is real world and you started with decimals, you can have a decimal answer. Okay, so x squared equals, and I'm not going to ask you to simplify something that's got a decimal, right? So the square root of that is 17.33. Oops, not x squared, sorry. Oops. X, sorry, my bad. Okay. Now, we can use our Pythagorean theorem to decide whether each triangle is a right triangle or not. Okay, so what that means is we have to figure out which one do we think should be the hypotenuse. Okay, so in A here, this looks like it might be the right angle, right? So we're going to say that's probably the hypotenuse. You can also look at which one is the longest one, because that would be the hypotenuse, right? Well, the square root of 113 is 3, whoops, hold on, I didn't put the right numbers in. 113 is 10.6, okay? The only reason you'd want to do that is to see, is it really the longest? It is, so that would be our hypotenuse. Whoops. So we're going to do 1 square root of 113 squared equals 8 squared, whoops, plus 7 squared. The square root of 113 squared, remember any radical squared is just the radicand, so that's just 113 equals 64 plus 49, and then 64 plus 49 is 113. So that is a true statement, right? So that means it is a right triangle. Now let's try this one. I think this one looks like the hypotenuse, right? Let's double check. 4 radical 95 is 38.99. So yes, it's the longest one. So that means the 4 radical 95 is what we square. 36 squared plus 15 squared. Okay, so again, remember that radical 95 squared is 95, but 4 squared is 16, so it's really 16 times 95. That's a big number. So 1520 equals 36 squared. And 15 squared is probably still 225, right? Yep. You never know. So that gives us 1520 equals 1521. That is not a true statement. That is not equal, right? And so this is not right. Okay? Now, we're going to actually know what it is here in a moment. So, you do not have to write all of this down. You need to write down this. And if the pictures make sense, then write them down. but I think the words make more sense and then our examples will help. Okay, so what this is saying is that if c squared, so if your hypotenuse squared is less than a squared plus b squared, then you get an acute triangle. Okay, if c squared is bigger, so if this is bigger, it means you've got this really long guy over here, which means you're going to have an obtuse angle, so you have an obtuse triangle. Okay, so let's go back over here. So in this case, our c squared was less than our a squared plus b squared. So it's not right, it is acute. Okay, so pause, write this down. Push play, do some examples. So we need to verify that they form a triangle, okay, which is weird that the book does not actually tell you how to tell you if it's a triangle or not. To know if it's a triangle or not, the two smallers have to add up to be bigger than the third, than the biggest one. Okay, so do the two smaller angles add up, smaller sides, add up to be bigger than the third side. So 4.3 plus 5.2 is 9 something, so it's bigger than 6.1. Okay, so it is a triangle. Okay, so now we need to decide, is it acute, right, or obtuse? Well, we need to put our numbers into our Pythagorean theorem. 6.1 would be our c squared. So 6.1 squared, we don't know. Is it equal? Is it less? Is it bigger? We'll find out. Most of you want to put an equal sign there, which is fine. I'm just trying to make a point. So 6.1 squared is 37.21. 4.3 squared is 18.49. And 5.2 squared is 27.04. So when I add those two up, I get 45.53, and 37.21 comes down. And so this side is bigger, right? So that means that c squared is smaller than a squared plus b squared. You don't have to write this step out if you don't want to, unless you need to understand that this was c squared. Okay, so if c squared is smaller, then it's acute. Okay? You do need to remember those two things. That if c squared is smaller, then it's acute. The way I remember that is that smaller means a smaller triangle, and to me, acute triangles are smaller than obtuse triangles. However, you need to remember that. Let's do one more. So if we look here, we need to make sure, remember that our two smaller angles add up to be bigger than the biggest angle. So 14 plus 11 is bigger than 15, that's for sure, right? If they're equal, it is also not a triangle, okay? So then we need to put them into Pythagorean theorem to figure out what kind of triangle it is. So this is going to be our c squared, right? So 15 squared, maybe, we don't know, bigger or smaller than 14 squared plus 11 squared. So 15 squared is still 225. We don't know. Why is 14 squared not coming to me? 196 plus 121, right? Yes. Okay. And then that plus that gives us 317. Interesting that all of these are the same. I need to work on my examples, huh? So that's smaller than that, and so that means that we have an acute triangle. That's all I got for you. Sorry it was so long.